Next, we have oligodendrogliomas. So the first thing that you should know is molecular genetics. Here we have IDH1 and IDH2 mutation, and also 1p and 19q chromosome deletion is involved. Okay, so the person commonly affected is the middle-aged people. Location is your frontal lobe, and the clinical feature, like just now, focal neurologic defects, headaches, and seizures. And then I think no, we don't have to explain because it's the same thing as just now. And gross, we okay. And for gross, this carcinoma it arises from the white matter, and it is well circumscribed, like the border is well defined, you can identify it very clearly, and it has cyst. Okay, and this carcinoma it is gelatinous and it has focal hemorrhage together with the classification. As for the microscopic, there are four things. First is the cells is regular with round nuclei, and also it has finely granular chromatin. So finely granular chromatin is your nuclear now. Your nuclear it is very round and it has fine granular chromatin inside your nucleus. Okay, and surrounding it you have your cytoplasm, right? And this cytoplasm is a clear halo, so which means here it's going to be dark and then the surrounding is going to be white, which symbolizes egg, your fried egg. So basically when you eat your fried egg, just remember that oligodendrogliomas look like that. And this this oligodendrogliomas microscopic feature is also it has delicate capillary network. So it has like delicate capillary network around this, which symbolizes like chicken wire. So these three things, fried egg, chicken wire, and also calcification, these three things is a triad for oligodendroglioma. Okay. And the last one for the non-glial glial cell carcinoma in this video is your ependymoma. So the molecular genetics involved is NF2 gene mutation on chromosome 22 22q. Okay, 22q. And the people commonly affected is children and also adult. And for the location is mainly on the fourth ventricle and also your spinal cord. And for the clinical feature, hydrocephalus, I have explained it earlier, so it's the same thing. And for the gross ependymoma, it is well demarcated, solid or papillary lesions. As for the microscopic, it's going to be a regular cell with round to oval nuclei and abundant granular chromatin. So which means your nucleus is going to be dark. And you will have the ependymal canals. Ependymal canals is like uh, yeah, for the ependymal canals. So it's like the tumor cells are arranged in circular or like tubular arrangements around or like clear around like a clear like a true empty canal. Okay, so yeah, so you have like an empty canal surrounding it, you have a circular tubular arrangement of tumor cells, that is ependymal canals. And then you have perivascular pseudorosettes. So perivascular pseudorosettes is where your tumor cells is going to surround your blood vessels, and your blood vessel is like circle, like a small circle, and then surrounding it will actually have a, like a clear cytoplasm, and after that only you'll have your nucleus. So it's like a rose, it's like a flower. Okay, that is perivascular pseudorosettes. So that is all about the glial cell carcinoma. Next, we have non-glial cell carcinomas. As I said, there's only two things that we are going to learn in this video. So the first one is meningioma. As I said, molecular genetics is very important, and molecular genetics involved here is the loss of chromosome 22q, and then you have NF2 mutation and also TRAF7 mutation, TRAF7 mutation. And the age group that is commonly affected with this meningioma is adult. And the location, actually for meningioma, it's like everywhere, right? Everywhere in your brain. It's not specified. So the location is not specified. As for the clinical features, there will be a like not. It's like a vague non-localizing, no non-localizing symptoms. Like you'll have headaches, you'll have seizures, like you'll have some kind of defects because you don't know where it is affected. So it's really non-localizing symptoms. Then after that, for the gross, so the mass is rounded and it is well defined with dural bases, and it is firm. It has not been like necrosis, no hemorrhagic, and it is gritty due to calcified samoma bodies. Okay, gritty means it's like chalk white, something like that. And for the microscopic, there's like several histologic patterns. For example, syncytial, fibroblastic, transitional, pseudomatous, secretory, and also microcystic. Okay, and for the medulloblastoma, again, the molecular genetic involved is WNT mutation and SHH mutation, and also you have isochromosome 17 with and without MYC implication. And people commonly affected by this medulloblastoma is children, and location is at your cerebellum. And for the clinical feature, it is hydrocephalus and also CSF dissemination. So this CSF dissemination is where your tumor is going to go to other spaces, okay, through your CSF. Because because if let's say your ventricle is affected by your hydrocephalus and it goes to your CSF, and CSF is where it will bring everything. Okay, so it's where everything will pass. So it brings to your CSF, and here you will have your drop metastasis, if I'm not mistaken. Okay, then you will have your gross and microscopic. As for the gross, it is well circumscribed and then gray and also friable. Plus, your microscopic is where you can see it is extremely cellular, hypercellular, hypochromatic nuclei with scant cytoplasm and abundant, like a lot of mitosis. And then it has homoerite rosettes. Okay, this is your classic microscopic feature of medulloblastoma. And that's all for this brain tumor video. And I will see you again in different topic. I don't know. Okay, I'll see you again. Bye.